All right, we're back with Algebra Lesson 87. But before I do that, I'm going to do one more from the last lesson on division of polynomials. And so I'm doing number 10 in today's lesson in your problem set. So you might want to do the same one to see if you get the same answer. It's a good way to check your work and see it spelled out so you can see where you messed up if you did do it and get it wrong. Otherwise, just follow along. So the problem is, and it's on page 365, is we have 2x to the third. And I want to just do this again because this one takes a while to sink in sometimes. Minus 3x squared plus 2x minus 4 divided by x minus 3. All right. So I'm going to rewrite this the correct way, and I'm going to put it in a division box. So I'm going to have x minus 3 out in front. That's the divisor. And they do their box like this. And so you have to rearrange them sometimes to get them in order. 3, 2, 1, nothing. So we have to have them in that order. So they already had it in that order, which is nice. 2x to the third minus 3x squared plus 2x minus 4. And remember, when you divide, you multiply, you subtract, and you bring down. And then if you have a remainder in this one, you take the remainder and you put it over your divisor as a fraction. We used to do that when we did division last year. So, and then when you're dividing two numbers in this equation, I always look at it as we're looking at the first one. We always want the variable first. We're looking at the first one, and this is just his friend that's coming along for the ride. That's how I look at him. And so we're going to look at the x, and if I were to say 2x to the third divided by x, what I'm basically saying is I'm taking away one of these x's. And so if I multiply x times 2x squared, I would get 2x to the third. So I divide, saying 2x to the third divided by x equals 2x squared. That's divide. Now I am going to multiply. X times 2x squared is 2x to the third. Now this is where his friend comes in. So now I also have to multiply negative 3 times 2x squared. Negative 3 times 2x squared is negative 6x squared. See how the exponents line up? So they're like terms. So now I subtract. Now when you subtract, and you already have a subtraction negative sign right there, you have to change that sign. So I just subtract. That makes that a negative, and this one's the opposite. It's the opposite of that, so that becomes a positive. So 2x to the third minus 2x to the third is nothing, so we have our 0. Then I have negative 3x squared plus, or minus, positive 6x squared. So you're finding the difference. I want to find the difference in these two, which would be 3x squared. Okay? Now I bring down. That's the next step. So I'm going to bring down plus 2x, and I start all over again. Let's go again. So now I'm looking at this one, and I'm looking at this one. These two are just along for the ride. 3x squared divided by x. So that would be 3x. So it's a positive 3x. 3x squared divided by x is 3x. So now I multiply. X times 3x is 3x squared. Now I have to do his friend. Negative 3 times 3x is negative 9x. Okay? Now I subtract. Subtract, bring that down. That's going to be the opposite of that, so I go ahead and change that sign. So 3x squared minus 3x squared is nothing. That's what we want. 2x plus 9x is 11x. Now we bring down. Minus 4. I used to write the little arrow just to keep me on track here. Okay? All right. So now, here's my new number. Ready to start over again with division. 11x minus x is 11. So plus 11. Now I multiply. X times 11 is 11x. That's what we want. Bring his friend into the picture. Negative 3 times 11 is negative 33. Good. Now I subtract. 11x minus 11x is 0. Good, that's what we want. And then I change the sign because it's minus. So 33 and negative 4, that is 29. That is my remainder, which I bring back up here, and I say plus 29 over the divisor, x minus 3. And this is your answer right there. So they come to you after a while. It is confusing to have two things here and have to do 2, 2, 2 all the way down. But with practice, you will get good at that. So I just wanted to do that one problem before we go into lesson 87. So that is just another review. And we may do another one until they quit including them in your problem set. You can always pause this video and do number 10 real quick and see if you got the same answer. All right, moving on to lesson 87, there's two parts. The first part is on more equations where you have subscripts and you solve for the missing variables. And this time you're going to have two variables, so you have to do substitution as well, so you get down to one variable. So that's how we do when we have more, or you could do elimination, but I always pick substitution if I have a choice. So in this example, we have the equation r subscript e times t subscript e is equal to r subscript w times t subscript w, and then they give me some givens. R subscript e is equal to 200, t subscript e plus t subscript w equals 9, and they want me to find t subscript e and t subscript w. So we're not going to know either one of those right off the bat. We're going to have to find one and then find the other. However many variables are, that's how many problems you're going to have to do. So now I'm going to go through to my original equation, and the reason they use subscripts is because what they're talking about normally when there's an r and a t is rate and time, and the subscripts are whose rate and whose time. And so you want the same, you want to know what you're talking about, so you use different letters, R and T. We're talking about rate here and time here, but we're talking about like Elizabeth's and Wesley's. So, or you're talking about east and west, you know, who knows. It's like an initial to indicate whose rate and whose time. So we're going to go in and we're going to substitute in what we do know. R subscript E is 200. So I'm going to put that in there right off the bat. And I think I know one more thing. Let me see. I may not know it yet. Did I? Oh yeah, I left one out. I knew there was a 250. R subscript W is 250. Okay, so I use parentheses always, because they're right next to each other. That means multiplication. So my parentheses are going to be right next to each other as well. So R subscript E is 200. T subscript E is one of the ones that we don't know. So I'm going to take those away and just put T subscript E. Equals R subscript W is 250. T subscript W, we don't know. That's the other one we don't know. Okay, so that's all I can do so far. But look here, I do know that if I add TE and TW, I get 9. So what I'm going to do is I'm going to isolate one of these. I'm going to subtract TW from both sides. That makes that go away, and that makes that T subscript E equals 9 minus T subscript W. Do you see that? Now I can put that right here. I can put that in where TE is. So I can put that right here. So I'm going to rewrite my problem, 200, and then I'm going to make 9 minus TW equals 250 times TW. See, now I only have one variable. I'm just going to solve for TW now. So I have to go through and I have to say, okay, 200 times 9, that's going to be 1800, and 200 times negative TW. So that'd be negative 200 TW equals 250 TW. So to isolate my variable, I'm going to get all of these on one side and leave this over here. So I'm going to add 200 TW to both sides to get them all together. So plus 200 TW. That eliminates it from this side, so then I have 1800 equals 450 TW. I'm going to divide both sides by 450 to isolate my variable, and I don't know that off the top of my head, so I'm going to use my calculator. Clear. 1800, remember this is a division bar also. 1800 divided by 450 equals 4. So T subscript W equals 4. Now I know, if I go to this easy one right here, if this equals 4, what does TE equal? That's the easiest way right here. TE plus 4 is 9, so that'd be a 5. So TE is going to be 5. And here is my answer. So you use the information they give you to solve for one, and then you can solve for the other. That is it for that lesson, that part of the lesson. The next part is on something completely different, and it's back to functions. And so these are pretty easy. We will revisit these many, many times. And so I don't think the problems they're going to give, oh, actually, we're in a couple of more lessons. We're going to do some more about where they make it a little more complicated. So back to this lesson, the part B for lesson 87 is talking about functions again. And so on the coordinate plane, this is super simple. Be so glad. Here's my coordinate plane. I'm going to do another one right here. All right, so let's say I have a function 2x equals y, okay? And if x, so here's my function box, x and y. So if x is 2, y is 4. If x is 3, y is 6. If x is 4, y is 8. Do you see that? So x and y can change. So it's not always just x is this, y is that, and that's the end of it. It's if x is this, then y is that. So that is, in essence, a very simple function. Now, let's say then we graph all those points. We graph 2, 4, we graph 3, 6, we graph 4, 8. Sometimes they're in a straight line, and sometimes they're not, because there are all kinds of functions. So let's say, for instance, when I graph the dots, and I connect them into a line, it makes a swirly line like that, okay? And then let's say a different function altogether, and when I graph those dots, those coordinates, it ends up making a circle, okay? So these are my graphed dots, and they have created a shape of some sort. Sometimes it's a line. We've done that before. Now, this is a test to decide by just looking at these if they're a function or not. So this is what you need to remember. A function has only one value for y, okay? So now that can change, but it can't be the same within the same x, okay? I know that sounds a little confusing, but you'll see what I mean. So this is the test you do. You do an imaginary vertical line in varying places on the coordinate plane. That's my imaginary dotted line. I'm going to do it again on this one. Okay. Now, if it's a function, my imaginary vertical line will only cross a y one place. Right here, down here, right here, and right here. It didn't cross it twice within one line. But on here, it crossed it here, and then again here. It crossed it here, and then again here. It crossed it here, and then again here. It crossed it 2 times, okay? that cannot be a function, so no function. But because this one, it only crossed it one time, this is a function. Okay? And that's all there is to this lesson. You're going to look at some examples in your book, and you're going to say, did it cross it twice by doing a vertical line, or did it cross it once? And that's it. So be glad. And so on the examples, I'm going to hold up the book. Maybe we can all see it together. So top of example 87.3, you see 3 coordinate planes right here, and there's 3 different squiggly lines. So the first one is not, the second one is, and the third one is not. Okay, so look at your book, and then on your homework, they have a couple of them you're going to do. Actually, they have 3. There's another one. So that's it. You can do that, and we will come back to visit that again later. But that's it for lesson 87.